We're going to start with the independent practice. This is 391 and 392. Something you guys should be working on Thursday night into Friday if you're looking to pace yourself, right? 2 days per lesson. So it's something you should be getting into on Friday. Number one, for the first leg of the Ramirez's family trip, their speed averages 68 miles per hour. All right, or instead of that H, I'm just going to do X, y equals 68x. The second leg is shown in the graph. They want us to compare these two, and we get 2 points. 155 and 6, 330. Our slope is y2 minus y1 over x2 minus x1. And let's see here, so 330, take away 55, so 245, 275, 273, 25, 330. All right, and then 5 goes in 5 once. 5 goes into 275. That's going to be 55 times. So our slope is 55 on the second part of the trip. And our equation is going to be y equals 55x. Compare the speeds for each part of the trip. So what that means is for the first leg of the trip, they averaged 68 miles per hour. Not bad. For the second leg of their trip, they averaged 55, so they went slower. Maybe they were going home, maybe they were more relaxed. For whatever reason, they went faster on the first leg, slower on the second leg of their trip. Let's take a look at number 2 now. Ooh, the late fees for a school library. Very interesting. So late fees are represented by this equation, C equals 25/100ths D. For C's total cost, D's number of days a book is late. We have a table of values, and this table has our X's laid out on top, days late, and our Y values, so the dependent variable, is on bottom. So 0.35, 0.7, 105. Well, that's interesting. So if it's not late, I've got to hear what this table's telling us. If it's not late, it'll be 0, 0. So we have the 1.35. So this is telling us that C equals 0.35D or 35/100ths D. In terms of the y-intercepts, we're looking at something that is tangible and measurable. So both graphs are going to start out here at the origin because we're not interested in any kind of negative values. It's got to be greater than or equal to 0. So we have 0.35 versus 0.25 because we're comparing the rates of change now. So the y-intercepts, since they're both going to be starting at the origin, they're the same, and the y-intercept, or the b, for both graphs is 0 because we start at the origin. What about the rates of change? Well, this library over here, the city library, are quite expensive, 35 cents per day. The school library only charges you 25 cents per day. All right. Now, part B, Shamar checks out one book at each library and returns both books 3 days late. What are the fees for each library? Well, one thing about the city library, it's in the table, guys. So use your literacy skills to read and understand. Now use your visual literacy with table to see, oh, it's going to cost him $1.05 at the city library. At the school library, if it's 3 days late, and it might look a little bit sloppy, so 0.25 times 3. It's going to cost him 75 cents at the school library. SL for school library. It's going to cost him $1.05 at the city library. There you go. All right, number 3, Matt and Seth purchase baseball cards each week. So we're given a table and a graph. So for Seth, we're given 1, 4, 2, 8, 3, 12. Once again, it's something that is tangible right here. So for Seth, we don't need anything negative. Starting out at the origin, and our slope is 4. All right. What about for Matt's collection? Ooh, Matt starts out up here at 20, and then he goes up more slowly. So for Matt, we have 0, 20, and 1, 22. All right, so for Matt, 0, 20, 1, 22. We get 2 other points we could use, 5, 30, 9, 38. It's your personal preference, all right? So y2 minus y1. And we haven't done this before, so I'll do it right now for us. I'll take the less common points. So 38 minus 30, y2 minus y1, over x2 minus x1. So we get 8 over 4. We get 2. And since we start out at 0, 20, so y equals 2x plus 20. Over here, for Seth, he gets y equals 4x. Who's going to have more cards in week 20? Substitute 20 in for x here. Seth in week 20 is going to have 80 cards. Cards are our units. We want to be able to do dimensional analysis, so please put those units in. And Matt, 2 times 20 is 40. 40 plus 20 is 60. So after 20 weeks, Seth is going to have more cards. When I say justify your response, so you can use the work that you did to justify because 80 is greater than 60. All right, last problem on this page is number 4. Shaw family's building a patio. One person can place the flagstone at a rate of 4.5 per hour. The equation S equals 11H represents number of stones S that 2 people can place in H hours. So for one person, we get 4.5 stones per hour. 2 people can do 11 stones per hour. How many more flagstones can 2 people place in 3 hours than 1? Well, 4.5 times 3 is 13.5 stones. Because once again, stones acts as our units. Right here, we have 11 times 3. We get 33 stones. Now, when we go back to compare and see if our answer makes sense, how many more? How many more? So 33 minus 13.5. So 2 people in 3 hours can lay 19.5 more flagstones. 19.5 more flagstones than one person. 5, 6, 7, and 8. And 5, 6, 7, 8. Reason abstractly on 5. We have 3 tables, and we need to write a function for each table. All right, now the first one, we have 1, 2, 3, 4, 8, 16, 24, 32. Function here is y equals 8x. For the second one, we have the 1, 2, 3, 4 for x. This time we have 16, 32, 48, 64. So we're going up by 16 each time. So y equals 16x. For our third one, 1, 2, 3, 4 for the x's. And our y's this time are going up by 32. So y equals 32x. That's step A. Write a function for each table. Step B, if you graph the points, the graph for which function is going to have the steepest slope. So we're talking about steepest. Steepest means the biggest. All right, so steepest, so we'd have 32, 32x, 16 for 16x, and then a slope of 8 for y equals 8x. So the steepest slope is the largest slope. So that's going to be y equals 32x, and that slope, guys, is 32. Which function, part C, has the least rate of change? The least. So the lowest rate of change is this one. Y equals 8x, because the rate of change is 8. So 8 is less than 16, both of which are less than 32. Boom. Okay, higher order thinking problem 6. Write a real world problem where you would want to compare rates of change for two different functions. Okay, be creative. Get to it, go for it, cool. Write some problem where you want to compare rates of change. Money's good, physical fitness is good. So maybe like bench press or squat numbers, 40-yard dash time, swim time, you know, I don't know, millions of different things you could do right there. So you come up with that, you write something, you be creative. We can talk about that on Friday during our Zoom session. 7. Ooh, explain why the graph, ooh, of y equals 3x plus 40 is never going to intersect the graph of y equals 3x plus 35. Guys, talked to this in another video. You have to know what's happened in previous chapters because math builds on itself. All right, so y equals mx plus b. And we did something in the last chapter with slopes and y-intercepts. So right here, our slopes are the same. Our y-intercepts are different. So what's going to happen right here is that these lines are going to run parallel. Why are they never going to intersect? Because we have the same slope and different y-intercepts. So if they constantly, for any point from negative infinity to infinity, if they're going to run parallel, they're never going to cross, period. Boom. It's from a previous unit. That should have been some review. I hope that was for you. Number 8, test practice. Ooh, exchange rate to convert US dollars to British pounds. T equals 61/100ths. D. For P's amount of pounds, D's number of dollars. 1 US dollar can also be exchanged for 69/100ths of a European euro. If you exchange $250 for pounds and for euros, which one of the following is true? All right, so I'm going to say E for euro. So euro is 69/100ths of a dollar. So let's see here. So if we want 250, so 250 times 0.61, it'd be 152.5 British pounds. And if we want 69/100ths euros per dollar, 172.5 euros. That's answer choice A. 152.5 pounds, 172.5 euros. B, 410 pounds, 362 euros. No. C, you receive $250. No. We're exchanging dollars for other currencies. D, you'll receive the same amount of pounds and euros. No, absolutely not, because 61/100ths is not the same as 69/100ths. Okay, guys, that's independent practice.